This is the last portion of the nuclear chemistry notes. In this video, we will cover half-life and radioactive decay series. So what is half-life? Well, every isotope has a rate of decay. This rate of decay tells us what quantity of an isotope has gone through radioactive decay. This rate is measured by the half-life of the isotope. Half-life is usually indicated by the variable T1/2. Half-life of an isotope is the time required for half of the isotope's nuclei to decay. It is also good to note that each isotope has a different half-life. For example, if we take carbon-14, this has a half-life of 5,730 years. But if we look at uranium, uranium-232 has a T half-life of 68.9 years. There's a difference. Now, at the half-life, only half of the isotopes remain. In other words, if we started with 100 grams of uranium-232, at the half-life, we should end with 50 grams of uranium-232. This will take about 68.9 years. There is an equation that you do need to know in order to perform half-life calculations. The equation that you need to know is that the final mass is equal to the initial mass times half to the nth power, and n is equal to the number of half-lives. I will, in the next video, you'll be able to see calculations dealing with this equation. So just to give you a visualization, let's say you started with 16 grams. This is your initial mass. After your first half-life, you have lost half, and you're only left with 8 grams, which is 50% of your original amount. Then you go through another half-life, so this is a total of 2 half-lives, and you lost half of the 8 grams. Now you're left with 4 grams. This is 25% of your original mass. You let another half-life pass, and therefore you have now completed 3 half-lives, and you lose half of your 4 grams. Now you're left with 2 grams. 2 grams is 12.5 grams of your original mass. And so this is what happens after each half-life. You lose half of the amount that is present. So when the radioisotope decays after each half-life, it forms a new element. This element may or may not be stable. If you produce an unstable isotope, this will continue to decay until a stable isotope is formed. This is known as a radioactive decay series. Radioactive decay series will just have an isotope decay through 2 or more radioactive decay processes until a stable isotope is reached. Now, you have either completed or are working on 2 extra credit problems where you have to determine the series of decay that an isotope underwent. Now you just know that what you're working on or what you were solving for was a radioactive decay series. Here is the decay series for uranium-238. As you can see, it goes through a series of decay, so alpha, beta, beta, alpha, so forth, until it becomes stable. Now, you have to note that each isotope has a different half-life. These half-lives right here, like uranium-238 versus thorium 234. Notice that they have different amount of years, days, minutes, seconds. And what you need to know is that the longer the half-life, the more stable the nuclide. If it's short, so for example, out of this whole entire list, this is the shortest one of all. So the most unstable isotope was polonium 214. And that is the end of radioactive decay series. So here's a quick joke for you guys. The old man says, when I was young, I was uranium-238. I felt so alive and dangerous. Then one day, I accidentally ejected an alpha particle. Now look at me, a spent old atom of lead-206. It seems all my life since then has been nothing but decay, decay, decay. I hope you enjoyed that. The next few slides are just about applications for radioactivity. Here is a Geiger counter, and a Geiger counter basically just checks how radioactive something is. And it goes through a process where argon is ionized, and so you produce an electron. And this produces some type of conductivity, and you can measure it on the Geiger counter of how high radioactive something is. Another example of radioactivity, this is called carbon-14 dating. This is how we determine how old certain fossils are, and it's basically the ratio of carbon-14 to carbon-12 that's in living organisms, and we just determine the age of fossils. Other things are radioactive tracers, and these are ingested in living organisms and they give off radioactivity. And so we can trace biological processes. So one of these are NMRs or MRIs. So if any of you guys have ever gone through an MRI, it's basically noticing the small amount of radioactivity. And we also use for food irradiation, where you give small doses of radiation and it slows down ripening and it gets rid of parasites. And sometimes high radiation is used to sterilize packages. And so these are just some of the applications that people use radioactivity for. Now the next video that you should see on the site is for calculating half-life, and so feel free to look at the video in order to learn how to calculate half-life problems.